telomerase. As we saw, the telomerase break off from the end of something very of a chromosome. This chemical, this telomerase can rebuild it, can help resemble the protected DNA. The telomere of a chromosome, this chemical list, the telomere that the chromosome is lost. Someday we will be able to take any cell and keep it alive, functioning and reproducing itself essentially forever through the use of telomerase. And in future, we may have virtually immortal nerve cells and immortal skin cells, whatever, because of the chemical telomerase can keep the telomere on the end of the chromosomes from getting any shorter.
The DNA in human cells, and as we learn more about the DNA in human cells and how it controls the growth and development of cells, then maybe we can explain a very important observation, that when we try to grow most human cells in a laboratory, they seem programmed to divide only a certain number of times before they die. Now, this differs with the type of cell. Some cells, like nerve cells, only divide 7 to 9 times in their total life. Others, like skin cells, will divide many, many more times. But finally, the cells stop renewing themselves, and they die. And in the cells of the human body itself, in the cells of every organ, of almost every type of tissue in the body, the same thing will happen eventually. Okay. You know that all of a person's genetic information is contained on very long pieces of DNA called chromosomes. 46 of them in a human cell. That's 23 pairs of these chromosomes of various lengths and sizes. Now, if you'll look at this rough drawing of one of them, one chromosome about to divide into 2, you'll see that it sort of looks like, well, actually it's much more complex than this, but it reminds us of a couple of springs linked together, 2 coiled up pieces of DNA. And if you stretch them out, you'll find they contain certain genes, certain sequences of DNA that help determine how the cells of the body will develop. When researchers looked really carefully at the DNA in chromosomes, though, they were amazed, we all were, to find that only a fraction of it, maybe 20 to 30%, converts into meaningful genetic information. It's incredible, at least it was to me. But if you took away all the DNA that codes for genes, you'd still have maybe 70% of the DNA left over. That's the so-called junk DNA, though the word junk is used sort of tongue-in-cheek. The assumption is that even if this DNA doesn't make up any of the genes, it must serve some other purpose. Anyway, if we examine the ends of these coils of DNA, we'll find a sequence of DNA at each end of every human chromosome called a telomere. Now, a telomere is a highly repetitious and genetically meaningless sequence of DNA, what we were calling junk DNA. But it does have an important purpose. It's sort of like the plastic tip on each end of a shoelace. It may not help you tie your shoe, but that little plastic tip keeps the rest of the shoelace, the shoestring, from unraveling into weak and useless threads. Well, the telomeres at the ends of chromosomes seem to do about the same thing, protect the genes, the genetically functional parts of the chromosome, from being damaged. Every time the chromosome divides, every time one cell divides into two, pieces of the ends of the chromosome, the telomeres, get broken off. So after each division, the telomeres get shorter, and one of the things that may happen after a while is that pieces of the genes themselves get broken off of the chromosomes. So the chromosome is now losing important genetic information and is no longer functional. But as long as the telomeres are a certain length, they keep this from happening. So it seems that by looking at the length of the telomeres on specific chromosomes, we can actually predict pretty much how long certain cells can successfully go on dividing. Now, there are some cells that just seem to keep on dividing regardless, which may not always be a good thing if it gets out of control. But when we analyze these cells chemically, we find something very interesting, a chemical in them, an enzyme called telomerase. As bits of the telomere break off from the end of the chromosome, this chemical, this telomerase, can rebuild it, can help reassemble the protective DNA, the telomere, that the chromosome has lost. Someday we may be able to take any cell and keep it alive, functioning and reproducing itself essentially forever through the use of telomerase. And in the future, we may have virtually immortal nerve cells and immortal skin cells or whatever, because this chemical, telomerase, can keep the telomeres on the ends of the chromosomes from getting any shorter. As we learn more about the